All right, now we're going to look at, this is going to be a shorter one. We're going to look at two distinct types of limits that are worth mentioning, which is piecewise and absolute value limits. Now, piecewise functions are just different functions that only show up during a range, right? You've probably seen them before. It looks something like this down here. It's basically this only shows up when x is less than 2. This shows up when x is equal to 2. Only shows up during a range, right? And remember, recall that a limit only exists when the limit approaches the same number. That means when it approaches a from the positive side is equal to when it approaches from the negative side, right? Now, remember that because a piecewise function, different functions only shows up during a range, they might not necessarily meet in the middle, right? They might not necessarily be continuous. So if there's a break in between, right, then the limit doesn't exist. So we need to make sure that the limit exists from both sides when solving this. And if it exists from both sides and it meets the same value, then that value would be its limit. Now, absolute values, I'm gonna be honest, probably don't show. I rarely seen it show up, but just in case, right? It's pretty easy. The easiest way is to just graph out the absolute value function, and then find the limit based on the graph. That to me is the easiest way to do it. So for this one, x minus 3 over x plus 3. Remember, absolute value functions always look something like, say this is the coordinate plane, has this, something like this, right? So we just need to figure out where the placements are. So what I like to do is plug in something, because we know that 3, because it'll be indeterminate, it'll be 0 over 0. We know that 3 is where it switches signs, it switches values. So which one's in the negative, which one's in the positive? So I'm just going to plug in 2, 1 less than 3, and 2 minus 3 is negative 1, and absolute value. So this is going to be negative, a negative value. So we know that, let's put a 3 here. We know that this is negative 1. Ooh. Negative 1. This is supposed to be a hole, sorry. And then that means when it's above 3, so say 4 minus 3 is 1 over 1, it'll be positive 1. Well, it's approaching 3 from the negative side, so approaching 3 from the negative side, it's going to approach negative 1 here. So our answer is negative 1. Just graph it out. That's the easiest way. Now, this is a little more complicated, I would say. Basically, we're trying to see as it approaches 2, we need to find out if the left side, as the limit from the left side is the same as the limit from the right side. Now, they have this 8 here to throw you off, because remember, a limit is not what it's defined at. So we don't really care what value it'll be when x is equal to 2. We care about what value it'll approach from the left and right side. So we're looking at this one and this one. So as it approaches from the left side, so when it's less than 2, so I'm going to write that out. As x approaches 2 from the left side, we're going to use this function because x is less than 2 here from the left side. Next, we just directly substitute this in, and we get 7. Cool. Now from the right side, that would be this function, because x is greater than 2. And we get, look at it, we also get 7. That means because this one is equal to this one, that means that the limit as x approaches 2 of this function is equal to 7, because they both are the same value and they both exist. Perfect. Short lesson for this one.